Okay, so what I want to talk about in this lesson today is the idea of the distance between 2 points. So we have 2 points here, and what we want to try and figure out is what is the distance from here to here, and how do we figure that out on a coordinated plane like we have here. So it's the distance between 2 points. Okay. So in order to be able to kind of work this one out, what we need to do is we need to kind of take into account this idea with triangles and what's known as Pythagoras' theorem. So what we can do is we can take this line here and we can turn it into a right angle triangle. So let's look at that to see what that would look like. So if we draw a line from here to here, and then if we join it up then with another line from here to here, okay, so they are joined up here. So what we have here is a right angle triangle. Okay, so this is 90 degrees. Now, with Pythagoras' theorem, so let's say if we call this side here A, and we call this side B, and we call this side C. Pythagoras' theorem, so Pythagoras theorem what it states is that A squared, so the length of A squared is going to be equal to the length of B squared plus the length of C squared. So whatever this length here is, whatever the length of the line is, that is going to be equal to this squared plus this squared. And that's the case with all 90 degree triangles. This longer side here is going to be equal to the two opposite sides squared, and this is what's known as Pythagoras' theorem. So what we can do is we can use this to take into account the size. We can use this theorem to work out what the length of this line is. So the line AB. So that's what we're trying to figure out. What is the length of that line, and taking into account the coordinates that we have. So what we can say then is, using this term, we can say, so we can call this, let's say, point, we'll call this point down here point C. So this is another point. So again, the parts of a triangle, every triangle has 3 points, and we create this point here now and we call it point C. Now, what we can work out then from this is that, so AB squared, so that's just your point from here to here, is going to be equal to AC squared. Okay, so line AC squared, so that's from this line here to here, plus BC squared, that's from here to here, plus BC squared. So what's this equal to then? So this is going to be equal to x2 minus x1. So this point here in relation to x, it's going to be, so this is x, this should be x2 and y2. So this point here in relation to the x-axis, so its x-axis is going to be x2 minus x1. So therefore that's going to be that squared. So x2, so if we think about, so it's got this point here, it's going to be this x value minus this x value. Plus the y value then is going to be y2 minus y1. So it's going to be equal to y2 minus y1. So this here, it simplifies into this if we just take into account the coordinates or the points. So this is going to have an x and a y coordinate as well, and that's what we're working out here. So then what we can say then is that if we want to get rid of the square here, the square, so this is squared as well. So squared. And what we mean by this here is this is x2. So let me just change this. So this is y2 minus y1. And this is all squared. So then this is going to be equal to, we can get what's called the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. And this is the formula then that we use to figure out the distance. So this is equal to AB. So the distance of AB then is equal to this. So this is the formula then that we use then in order to work out the distance. So what I've done there is I've just derived the formula and just kind of showed you where it's coming from. So if we think about the values then that we have, so we have x2, this x2 value, this comes from here, so it's this point here, and the x1 is here, x1 is here. The if we take then the y2, okay, that looks the same color, so y2, so this y2 value comes from here, and the y1 value then comes from here. And we can use this then to figure out the distance between these 2 points. And this is the formula that we would use. So let's just work through an example of that. So imagine we have, let's say, so point A, let's just write this in. So point A is 3 and 2, and then point B is 7 and 5. So you just have your, I'm just going to do this very roughly. So we have, let's say, our 2 points, and then we have our line going through it. So we have the 2 points then. We have point A at the end here and point B here. So, and this is point A and this is point B. So what we want to do now is we want to use this formula here to figure out what is the length from point A to point B. So the first thing you really do is you want to label so we have point A. So on the left hand side, this coordinate is going to be the x coordinate. So this is going to be x1. Therefore, on the left hand side in this point, this is going to be the x coordinate, so this is going to be x2. Okay. Then on the right hand side, these are the y coordinates, so the first point is going to be y coordinate 1, and the second point is going to be y coordinate 2. So all you're doing is you are identifying which is x1 and which is x2 and which is y1 and which is y2. So what you do is you always let the first point be x1 and y1 and the second point be x2 and y2. So now once we have these, what we can do is we can just plug them into this formula here. So what we know then is that the formula, so it's x2 minus x1, so x2 is 7, so it's going to be 7 minus 3, and then this is all squared, plus y2 minus y1, so y2 is 5 minus 2, and this is all squared. And then what we have to do then is we have to get the square root of all of that. So the square root of all of that. And that's going to be equal to the point AB, the distance between point A and B. So again, what we do is we follow BIMDAS, so we have to do brackets first. So what's inside the brackets? So let's do that. Let's work through this. So 7 minus 3 is going to be 4. So that's 4 to be squared, plus 5 minus 2 is going to be equal to 3 to be squared. And then this is all inside a square root like so. So then what we do is we just square these. So 4, we multiply them out. So 4 to the power 2 means 4 multiplied by 4. So that's equal to 16, plus 3 by 3 is equal to 9. Okay, so it's 3 plus 9, square root of 3 plus 9. And then what we do is we just add these together. So it's going to be the square root of 16 plus 9 is equal to 25. And then the square root then of 25 is equal to 5. 5 5s are 25. So therefore, the distance then, so based on this, the distance between A, B is going to be equal to 5 using this formula here. So generally when we write like at the point, this means the distance between A and B, the line segment A and B. We use these two kind of bars either side. So it's 5. So it's just another formula, and that's where it comes from. And the idea is that you're using the distance between 2 points. So basically the distance between 2 points is going to be, so it's x2 minus x1 to be squared plus y2 minus y1 to be squared, and then you get the square root of that, like what we've done here with this example. Okay, so hopefully that makes sense, and we'll get you to work through some questions in relation to it. Okay guys, thank you.